In this video, we will construct a clipping circuit. Like the name suggests, a clipping circuit clips off a certain part of the output waveform, while the rest of it remains the same or undistorted. And you might have already come across a clipping circuit, which is a half-wave rectifier. And we are going to employ the same devices in this circuit as well. And there are two types of clipping. One where the negative half of the waveform gets cut off, which is the negative clipper, and the other where the positive gets clipped off, which is the positive clipper. And then we make a circuit that combines both of them, and that is a double-ended clipper. So let's start with the negative clipper. For that, we'll need an AC voltage source. So there is AC voltage here, and the peak voltage can be 4. Next, we can take the ground. And a diode. Diode, we can choose 1N4007G, and a resistor of 10K. Now we have to connect these. So now we want the output to follow the input in the positive half and clip off in the negative half. So for that, we have to forward bias the diode. We can rotate it. So forward bias the diode. And now we want to see the input across the input, and we want to see the waveform across the output and the input. So for that, let's take a oscilloscope from the right here. And A can be our input. And B can be the output across the diode. And since we want to be able to differentiate between the input and the output waveform, let's change the color of the output to blue. And then we can run it and check. So the scale, we can change the time scale so it's visible. And we can change this as well to make it slightly better. So now we can see that we were expecting the output to get clipped off at 0, but it doesn't do that. It gets clipped off at a little lesser than 0. And that is because this diode is a practical diode, and it will have a drop of 0.7 volts across it. So to get rid of that, what we can do is we can add a reference voltage. To add a reference voltage for that, we can just take a DC voltage. Just have DC power. And so now the drop across this diode is 0.5 volts. So for that, we need, this is negative and positive 0.5 volt drop. And so here we need a 0.5 volt to nullify that. And now we can see that it is getting clipped off at exactly 0. And so this is the bias voltage we have added. And this is the negative clipper. So now for the positive clipper, all we have to do is reverse bias this. And for that, we can just remove this and flip it vertically. So in this case as well, this here it is positive and negative 0.5 volt drop. So here also it should be negative and positive. So we can just change this to minus 0.5 and run it. And okay, let's change the segment color here. Yeah, so now we can see that the positive is getting clipped off. And that is a positive clipper. And now we can see the negative clipper, which is just the combination of both positive and negative. And we can run it. So you can see here, in this case, blue is the input and red is the output. And we can change how much we need to clip using these reference or bias voltages.